Okay, welcome to the second video of Lesson 2 from Unit 8, Part 2, Proving Triangles Similar. So now we're up to question number 3. We want to prove not only that these two triangles are similar, but the corresponding sides are in proportion and the product of the means equals the product of the extremes. I started to do this already and I ran out of ink on my pen. That's why you saw a bullet there. So I do this in bullet points. And we're given that SU is parallel to BY. We're going to put that down as a given. SU parallel to BY because given. Remember, we need to prove the triangle similar. In order to do that, we need to get two angles of one triangle congruent to two triangles of the other triangle. We know the lines are parallel, so we could use this as a transversal. If these are the parallel lines, you see the Z there. So you should know that you could get, for example, angle S is congruent to angle B. You should know the reason. You should write it down now. If two parallel lines are cut by a transversal, then alternate interior angles are congruent. So we got those two angles congruent. Now, we could get these angles, because they're vertical angles, to be congruent to each other, or we could actually be a little lazy and get these angles to be congruent for the same reason. In this particular case, the transversal would be UY, and the Z would go that way, but you get the same reason, so that's actually probably the quickest way to do it here. We'll get angle U is congruent to angle Y because same reason as above. And now we have enough information to prove the triangles are similar. Triangle SUZ is similar to triangle BYZ because of angle-angle similarity, and as I already said, that's the primary reason why triangles are similar in proofs. Now we're ready for the proportion. SZ over BZ is equal to UZ over YZ, and we know the reason. You should be able to pause the video and write it down yourself. If two triangles are similar, I'll use the symbol for similar here, then corresponding sides are in proportion. Okay? And then finally, we have the last thing that we learned. SZ times YZ equals BZ times UZ. And again, pause the video so you could write down the reason. In a proportion, the product of the means equals the product of the extremes. Okay? So that's how you do one of these proofs that have not only proving triangles similar, but the corresponding sides are in proportion and the product of the means are equal to the product of the extremes. You could try the next problem on your own. Here, there's one difference between this problem and the previous problems. On the regions, they don't always write down given. Sometimes they'll just state the givens in a paragraph form, something like this. You're given that GI is parallel to NT and IN intersects GT at A. The rest of the proof is kind of similar to what we've done already. And what we'll do is, we'll write down the givens. Mainly that GI is parallel to NT. Because of given. We also know that IN intersects GT at point A. That's a given. That given is primarily so that we can use vertical angles, which I think we're going to do in this particular case, because why don't we practice that skill? Let's start first by finding the angles that come from the fact that we have parallel lines. So if GI is parallel to NT, we can find the Z, or the alternate interior angles, this way, and we can get angle I is congruent to angle N. And you know the reason, we had it in the previous proof. If two parallel lines are cut by a transversal, then alternate interior angles are congruent. And I could do the shortcut here, just get G is congruent to T. But let's just practice this skill. Let's call this angle 1 and angle 2. And let's say angle 1 is congruent to angle 2. Because you know what kind of angles these are. What you say in your proof is because intersecting lines form congruent vertical angles. And you need the word congruent here, and you need the word vertical to get full credit, okay, if you're going to use that reasoning. All right, now we can prove the triangles are similar. So we have triangle GIA is similar to triangle TNA because of angle-angle similarity. Now you know you can do the proportion. IG over NT equals GA over 8T, because if two triangles are similar, then the corresponding sides are in proportion. And finally, IG times AT is equal to NT times GA. And we know that reason. If in a proportion, the product of the means equals the product of the extremes. In a proportion, the product of the means equals the product of the extremes. And I'd like to add one additional thing, and that is that when you do a proof, if you're proving triangles similar, these things obviously follow, but sometimes they might not tell you to prove the triangle is similar. Sometimes they might just tell you to prove this, but you have to know that you have to prove triangles similar first. In fact, we'll see in tomorrow's lesson, in the next lesson, that if you're asked to prove this with nothing else, you've got to do this first and then this. So these three steps always have to go in this particular order. So there's really, it's always going to be the same procedural steps. This, then this, then this. Whether they explicitly tell you to do them, or if they just tell you to do this, you have to know to do this first, then this, and finally this. Okay, please do your homework, and I'll speak to you soon for lesson 3.